In this section, we will be discussing transformation formula. Now, previously we have discussed about the trigonometric ratios of compound angle. So, compound angles means it's the sum or difference of two angles, and when we take the trigonometric ratio of that particular angle, we get trigonometric ratios of compound angles. Let me state the four formulas that we have obtained. So, sine of the compound angle A plus B, so that's given by sine of angle A times cosine of angle B plus cosine of angle A times sine of angle B. Fine. Then we define sine of A minus B. So that will be given by sine of angle A times cosine of angle B minus cosine of angle A times sine of angle B. Then we also define the trigonometric ratio of the compound angle A plus B for cosine. So cosine of A plus B is given by cosine of A times cosine of B minus sine of A times sine of B. And finally, we have cosine of A minus B. So that's given by cosine of angle A times cosine of angle B plus sine of angle A times sine of angle B. So we have four formulas. So let's name them as equation 1, equation 2, 3 and 4. Now what we'll do, we'll begin by first adding 1 and 2. So if we add 1 and 2, on the left hand side we have sine of A plus B added to sine of A minus B. And when you come to the right hand side, we see here that the second term, cosine of A times cosine of B, that is going to get cancelled out. We'll be only left with the first term, and since it's repeating twice, so we have 2 times sine A times cosine B. So this gives us a new formula. So the product sine A 2 times sine A times cosine B, that's actually the sum of sine A plus B plus sine A minus B. Similarly, if we do 1 minus 2, then we're going to get sine of A plus B minus sine of A minus B. So this will be equals to, the first term will get cancelled out, we'll be only left with the second term. So we have 2 times cosine of A times sine of angle B. Fine. Similarly, what we can do, we can add 3 and 4. So 3 plus 4, so this will be equals to, we have cosine of A plus B plus cosine of A minus B. Now we see here that the second term of both the two expressions will get cancelled out, and we'll be left with 2 times cosine of A times cosine of B. And then finally, if we subtract 4 from 3, then we're going to get cosine of A plus B minus cosine of A minus B. So that will become equals to negative 2 times sine of A times sine of B. So here we'll have to be a little bit careful with the sign here. Everything else will be positive. So these are known as transformation formula, because if we have the product of two trig function, for instance sine A times cosine B, that converts into the sum of two trig functions. Similarly, we can pick up any product. So we can see here in the second one, cosine A times sine B, so their product gets converted to the difference between two trig functions. Right? So even if you forget this formula, what you can always do is always derive it in the way that we did here. But for this, of course, you'll have to remember these four ratios, the trigonometric ratios of these compound angles. So let's try to understand or apply this particular idea with the help of few problems. So here we have 5 trig functions. We need to express their following products as a sum of difference of sines and cosine. We'll begin with number 1. So here we have 2 times sine 5 theta times cosine theta. Now this has a close resemblance with 2 times sine of angle A times cosine of angle B. So whenever, there's a trick to remember this. If the sine function comes first, in the sense that means if we give precedence to angle A and we have sine of that angle A, then this will be always sine of A plus B plus a sine of A minus B. And the other way around, if cosine of A comes first followed by sine of B, then we'll have a negative sign here. Okay, so here in that case, here A is equivalent to 5 theta and b is simply equals to theta. So what we'll do, we'll substitute it here. So that means 2 sine 5 theta times cosine theta will become equals to sine of a plus b. So we'll get 6 theta plus sine of a minus b. So a minus b, we have 5 theta minus theta, so that's simply 4 theta. So this is the expression. So we have converted the product into the sum of sines. Fine. Coming to the next one, so now we have 2 times cosine of 4 theta times cosine of 3 theta. Now when both the product are cosine, so that means it is going to be a sum of 2 cosine function. So here we're going to use the fact that 2 times cosine of theta times cosine of phi, so that will be equivalent to cosine of theta plus phi plus cosine of theta minus phi. Fine. So let's substitute these values here. So 2 times cosine 4 theta times cosine of 3 theta, so that will become equals to cosine of, so we need the sum first, so 4 theta plus 3 theta will be 7 theta plus cosine of 4 theta minus 3 theta, so that's simply theta. Now we have 2 times cosine 4 theta times cosine 3 theta expressed in terms of the sum of 2 cosines, cosine of 7 theta plus cosine of theta. Moving on to the next one, we have 2 times sine 3 theta times sine theta. So we have 2 times sine 3 theta times sine theta. Now this time we have the product of 2 sine function. So whenever we have the product of 2 sine function, that means 2 times sine A times sine B. So this must be actually the difference of 2 cosine function. We have cosine of A plus B minus cosine of A minus B. However, we have to be a little bit careful here. There is a negative sign that's involved here, meaning we have to multiply both sides with negative. So we'll take care when we do the problem. So let's do that. We have 2 times sine 3 theta times sine theta. So this will be equals to cosine of 3 theta plus theta minus cosine of 3 theta minus theta. But we have to multiply both sides with a negative sign. So we have negative of the entire difference of the cosine function, and that finally gives us cosine of, so we'll use this term first, 3 theta minus theta will be 2 theta minus cosine of 3 theta plus theta, so that's simply 4 theta. Let's go to the next part. So here we have sine 75 degree cosine 15 degree. So let's do that. Sine 75 cosine 50. Number 4, sine 75 degree cosine 15 degree. So here we'll use the fact that sine of A, 2 times sine of A times cosine of B. So since sine of A is coming first, so we have the sum of 2 sine functions. So we get sine of A plus B added to sine of A minus B. Fine. Now in a case, here we have sine 75 degree times cosine 15 degree. The 2 is missing here. Oh, that's fine. So what we'll do, we'll multiply by half and multiply with 2. So we get 2 times sine 75 degree times cosine 15 degree. Now we can apply the formula. So we get sine 75 plus 15, so that's going to be 90 degree, plus sine 75 minus 15, so that's 60 degrees. That will be equals to half. So sine 90 is 1, and sine 60 degree, that's square root of 3 over 2. And finally we get half plus square root of 3 over 4. So this is going to be the value of sine 75 degrees times cosine 15 degrees. And finally we come to the fifth part. We have cosine 75 degree cosine 15 degree. Then number 5, we have cosine 75 degrees times cosine 15 degree. Now here we will be using the formula that 2 times cosine of A times cosine of B. When the products are both cosine functions, then this is going to be the sum of 2 cosine functions. So we have cosine of A plus B added to cosine of A minus B. Fine. Now in our case we have the 2 missing. So what we'll do, cosine of 75 degree times cosine of 15 degree, we will multiply by 2. So we have 2 times cosine 75 degrees times cosine 15 degree. Now 2 is an extra factor that we multiplied from our side, so we'll also have to multiply with half. So we have half of cosine 75 plus 70 degrees plus 15 degrees plus cosine of 75 degrees minus 15 degrees. Right? Let's compute the value. We get half of cosine 75 plus 15, so that's 90. So we have cosine 90 degree added to cosine of 75 minus 15, so that's 60 degrees. We get half of the cosine 90, that's 0. Cosine 60, that's simply half. So we have half multiplied to half. Our final value is going to be 1/4. Let's move on to the next problem. So we need to determine the value of the given trigonometric expression. Let us begin. So here, if we consider the first term, so here we have 2 times the product of 2 cosine function. We know that if we have 2 times cosine of A multiplied to cosine of B, so that's simply the sum of 2 cosine functions. So we have cosine of A plus B plus cosine of A minus B. Now in our case, here we have the value of A. So here A is equivalent to pi over 13. And we have B, so that's equivalent to, so let's do one thing. Let's take A equivalent to 9 pi over 13 and B as pi over 13. Fine. Now, we'll have to find out 2 times cosine of pi over 13, cosine of 9 pi over 13. So this will become equals to cosine of A plus B. That means 9 pi over 13 plus pi over 13. Added to cosine of 9 pi over 13 minus B, so B is pi over 13, which is equals to cosine of 10 pi over 13 plus cosine of 8 pi over 13. Fine. So now we can rewrite a given expression. So we have 2 times cosine of pi over 13 times cosine of 9 pi over 13, added to it cosine of 3 pi over 13 plus cosine of 5 pi over 13. So this can be also expressed as, so we will split the first term into 2 parts as cosine of 10 pi over 13 plus cosine of 8 pi over 13 plus with the remaining 2 terms cosine of 3 pi over 13 plus cosine of 5 pi over 13. Okay. So this is the value that we need to find. So let's work with cosine of 10 pi over 13. Now 10 pi over 13 can be also expressed as the numerator portion 13 pi minus 3 pi. So 13 pi minus 3 pi, that's 10 pi. We're just rewriting the numerator portion. Then similarly coming to the third part, so here we have cosine of 13 pi minus 5 pi, because we know that 13 minus 5 is 8. So the numerator, we're just splitting into 2 parts, divided by 13, and we're not going to change the third and the fourth term. So we have cosine of 3 pi over 13 plus cosine of 5 pi over 13. Okay, so now we can further simplify it to get cosine of, so here we have 13 pi over 13, so we get cosine of pi minus 3 pi over 13. The second term will become cosine of pi minus 5 pi over 13. Then the remaining 2 terms, cosine of 3 pi over 13 plus cosine of 5 pi over 13. Okay. Now, the reason why we split or wrote the first term and the second term in this particular fashion, because we know that cosine of pi minus theta was the value. Since here we have pi, so pi is actually nothing but 2 times pi over 2. We have an even multiple of pi over 2. So whenever we have an even multiple of pi over 2, so the cosine function is going to remain unchanged. We have cosine, but the new angle is going to be now theta. Also, 2 times pi over 2 means we are in the second quadrant. And we are subtracting theta from it, but theta is an acute angle. So it's still going to lie in the second quadrant. But in the second quadrant, cosine is negative. Only the sine and cosecant is positive, everything else is negative. So that means cosine of pi minus theta is equivalent to negative cosine theta. This means that we can now write the first term as negative cosine of 3 pi over 13. Similarly, the second term will become negative cosine of 5 pi over 13. And we're left with the remaining term cosine of 3 pi over 13 plus cosine of 5 pi over 13, and we see that all the terms cancel out, and this leaves us with a value of 0. So that means the value of the given expression, this given trigonometric expression, is going to be equals to 0. Fine. Let's go to the next problem. So we need to determine the value of cosine 20 degree times cosine 40 degree times cosine 60 degree times cosine 80 degree. Let us begin. So here, before even solving, we know the value of cosine 60 degree. We know that cosine of 60 degree, that's equals to half. So let's substitute the value here, and we're going to get, so let's start with the expression cosine 20 cosine 40 times cosine 60 times cosine 80. So this will be equals to half. So here we have replaced the value cosine 60 with half. We're left with now cosine 20 degree times cosine. So we're going to use 80 degree first, then we're going to have cosine 40 degree. There's a reason, because we're going to combine cosine 20 degree with cosine 80 degree. Now we have a factor 2 missing here. What we'll do, we'll multiply by half and then also multiply with 2. So we get 2 times cosine 20 degree times cosine 80 degree, whole multiplied to cosine 40 degree. So we get 1 over 4 multiplied to it will be, so since we have the product of two cosine function, so this will become the sum of two cosine functions. So here we have cosine of 20 plus 80, so that's 100 degrees, plus cosine of 20 minus 80, so that's negative 60 degree, but cosine is an even function, so we're going to get cosine 60 degree times cosine of 40 degrees, right? Let's multiply cosine 40 degree to each of the terms within the parentheses. So we have cosine of 100 degrees times cosine of 40 degrees plus cosine of 60 degrees times cosine of 40 degrees. Now, what we can do, we can replace the value of cosine 60 degree with half, and also here we have product of two cosine functions, so we're going to multiply with half and 2. So we have half times 2 times cosine of 100 degrees times cosine of 40 degrees plus cosine 60 will be half, so we have half cosine of 40 degrees. Now we can take out half as the common factor, so we are going to get 1 over 8. Multiplied to it will be 2 times cosine 100 degrees times cosine 40 degrees plus cosine 40 degrees. Right. That will be equals to 1 over 8. So we have product of two cosine functions. So this will simply become cosine of 100 plus 40. So that's 140 degrees plus cosine of 100 minus 40. So that's 60 degrees. So we have cosine of 60 degree plus cosine of 40 degrees. Okay, we're almost there. Now we can break down cosine of 140 degree as, so let's do it here. So here we have cosine of 140 degrees. So that can be also expressed as cosine of 180 degrees minus 40 degrees. Means exactly the same thing, but there's an advantage to it. So here cosine of 180 degrees, so that's 2 times 90 degree minus 40 degree. So here we can see that we have an even multiple of 90 degrees. So cosine is going to transform to cosine only, and the new angle will be 40 degree. But 2 times 90 means we are in the second quadrant, and since 40 is an acute angle, so you are still going to lie in the second quadrant where the cosine function is negative. That means cosine of 140 degree is equivalent to negative cosine 40 degree. So we get 1 over 8 multiplied to cosine of 40 degree, negative cosine of 40 degree plus cosine of 60 degrees, so that's half, plus cosine of 40 degree. So the first term and the third term cancels out, and we are left with 1 over 8 multiplied to 1 over 2. So that's nothing but 1 over 16. So this is going to be the value of a given trigonometric expression. The product of cosine 20, cosine 40, cosine 60 and cosine 80. Now let's move on to the fourth problem. Problem number 4. We need to determine the value of the given trig expression. This problem is quite similar to the previous one. I mean, the procedure will be the same. So let's try to find out the value. Now, clearly we can see here there is product of two sine function. So which of the formula we are going to use? So then whenever we have 2 times sine of A times sine of B, so this becomes equals to cosine of A minus B minus cosine of A plus B, because there is a negative sign involved. So what I've done, I have multiplied the negative sign with the right hand side, so that's why the second term became the first term and the first term became the second term. Okay, this is only for remembering. Now we'll be using this particular idea. So let's start from the expression. So we have sine 10 degrees times sine 30 degree multiplied to it is sine 50 degrees times sine 70 degrees. So we know the value of sine 30 degree, so we can use it as half. So we have half and multiply to it as sine 10 degrees times sine 50 degrees times sine 70 degrees. Okay, so let's begin by first combining sine 10 degree and sine 50 degrees. But we have a factor 2 missing here. That's fine. What we can do, we can multiply and divide by 2. So 1 over 4 multiplied to it will be 2 times sine 10 degrees times sine 50 degrees. And multiply to it is sine 70 degrees. So this will be equals to 1 over 4. So we can use this particular formula. So here A corresponds to, let's take A to be 50 degrees and B to be 10 degrees. Because we have cosine function, so it's not going to be a big issue here. So we have cosine of A minus B, that means 50 minus 10, so that will be 40 degree, minus cosine of 50 plus 10, so that's 60 degrees. So multiply to it will be sine 70 degree. So this will be equals to 1 over 4 times, now what we'll do, we'll multiply cosine 40 and cosine 70. We have cosine of 40 degrees times sine 70 degrees minus cosine of 60 degrees times sine 70 degrees. And now furthermore we now have 1 over 4 times, what we'll do, we'll again do one multiplication with half and with 2 times cosine of 40 degrees times sine 70 degrees minus cosine of 60. Cosine of 60, that's half, so we have half times sine 70 degrees. Fine. Now here we have the product. So let's do one thing. Let's pull out the half from the parentheses. So we have 1 over 8 and multiply to it will be 2 cosine 40 degrees times sine 70 degrees minus sine 70 degrees. Fine. So here we have a formula where we have the product of a cosine function and a sine function. So clearly the angle of sine is greater than the angle of cosine. So here we'll have to use the formula 2 times sine of angle A times cosine of angle B. We're just making an assumption here that A is greater than B. So this will be equals to the sum of two sine functions. That means we have sine of A plus B plus sine of A minus B. Fine. So let's use this formula. We're going to get 1 over 8 and multiply to it will be sine of 70 plus 40. So that's 110 degrees plus sine of 70 minus 40, so that's 30 degrees. So we have sine 30 degrees minus sine 70 degrees. Fine. Now here we have sine 110 degrees. Let's work with this. We have sine 110 degrees. This can be also expressed as sine 180 degrees minus 70 degree, 70 degrees. So that corresponds to 110 degrees. And here we have sine of 180 degrees. So 180 degree can be expressed as the product 2 times the 90 degrees minus 70 degrees. The reason why we wrote in this fashion, because we have an even multiple of 90 degrees. So whenever we have an even multiple of 90 degree, the sine function is going to remain as the sine function, but the new angle is now going to be 70 degrees. And we are in the second quadrant where the sine function is positive. So that means sine 110 degree, that's equivalent to positive sine 70 degrees. So we have positive sine 70 degrees plus sine 30 degrees, so that's 1/2 minus sine 70 degrees. So the first term and the third term cancels out. Now we are left with 1 over 8 multiplied to half, so that gives us the value 1 over 16. So that means the value of the trig expression sine 10 degrees, sine 30 degrees, sine 50 degrees times sine 70 degrees, that comes out to be 1 over 16. Okay, let's move on to the final problem. Problem number 5. We need to determine the value of the given trig expression. So let us begin. So here we have sine 20 degrees times sine 40 degrees times sine 60 degrees times sine 80 degrees. Now clearly sine 60 has a standard value which is square root of 3 over 2. So square root of 3 over 2 and multiply to it will be sine 20 degrees times sine 40 degrees times sine 80 degrees. Okay, so up until now in the previous problems we have always considered the first and the second second trig function. So let's do one thing. Let's use the second and the third function and let's see what kind of result that we get. So here what we'll have to do, we'll need a product 2 here. We'll need a factor 2 here. So what we'll do, we'll multiply and divide by 2. That gives us square root of 3 over 4 times sine 20 degrees. So we're going to keep it outside, and we have now 2 times sine 40 degrees times sine 80 degrees. Right. So this will be equals to square root of 3 over 4 times sine 20 degrees. Now here we have the product of two sine function. So that means we have the difference of cosine function. So we're going to get cosine of a minus b. So if we consider 80 to be a and 40 to be b, so we have 80 minus 40, so that's 40 degree, minus cosine of a plus b. So 80 plus 40 is going to be 120 degrees. Fine. Okay, now let's find out the value of cosine 120 degrees. So that's a standard value, but we'll need to do a little bit of computation here. Cosine of 120 degree, that's equivalent to cosine of 180 degree minus 60 degrees. So this will be equals to cosine of 2 times 90 degrees minus 60 degrees. So this will be cosine of 60 degree, but we are in the second quadrant, so we'll get negative cosine 60 degrees. So that means that value comes out to be negative half. Let's substitute that value here. So we have square root of 3 over 4 times sine 20 degree, and multiplied to it will be cosine of 40 degree. So we have negative cosine 120 degrees, so this will become positive half. So we get square root of 3 over 4 multiplied to, also we're going to multiply sine 20 degree to each of the terms within the parentheses. So we have sine 20 degrees times cosine 40 degrees plus half sine 20 degrees. Fine. So we're going to pull out half from within the parentheses. So this is going to give us square root of 3 over 8. And then we have 2 times sine 20 degrees times cosine 40 degrees plus sine 20 degrees. Now we have cosine 2 sine 20 degree cosine of 40 degree. So here we're going to use the formula that 2 times sine a cosine a. So here we have cosine a times sine b. So that becomes equals to sine of a plus b minus sine of a minus b with difference of the sine function, assuming a is greater than b. That means we now have square root of 3 over 8. And within the parentheses, 2 sine 20 cosine 40 is going to be sine. This is a 40 degrees a and b is 20 degrees. So we have 40 plus 20, that's 60 degrees. So sine 60 degree minus sine 40 minus 20, so that's 20 degree. Negative sine 20 degree plus sine 20 degree. So we have the second and the third term cancelling out, and we're left with square root of 3 over 8 times sine 60 degree. Sine 60 is square root of 3 over 2. So that leaves us with 3 over 16. So this is going to be the value of the given trig function. We get 3 over, this will be equals to 3 over 16.